Welcome to this presentation on Casey et al. 2011. Neural correlates of delay of gratification. This is for the OCR A2 and AF psychology specification, so if you're doing this, then make sure you know every detail from the study for your exam. It's going to be quite an in-depth presentation, but you just have to know it, so let's crack on. So first of all, we need to know about the relation to the biological area of psychology. And here's just some points outlining this relation. So biological and genetic factors are known to influence the way in which individuals behave. This core study investigates how specific areas of the brain impact on a person's ability to resist the temptation of rewarding stimuli. We also have to know about Metcalfe's and Michel's hot system and cool system that are basically found in parts of the brain known as the ventral striatum and the inferior frontal gyrus. These two systems impact a person's ability to delay gratification when they are presented with rewarding stimuli. Theories behind the study. Now, when I did psychology, you don't specifically need to know every single theory there is behind a study. Just choose one or two of these bullet points, remember them, commit them to memory, and you should be good to go for the exam. So let me just go for a few of these. Being able to resist alluring cues / temptation in favour of long-term goals is essential in achieving individual, societal, and economic success. The capacity to control impulses can change as we get older. Being able to delay gratification depends on cognitive control. There are many different cognitive strategies that can be used to help delay gratification. Correlation has shown a relationship between an avoidance of risky behaviour and greater excitation in the right inferior frontal gyrus. Or gyrus, I'm not sure how you pronounce that word, but as long as you know how to spell it, that's fine. It has also been found that the ventral striatum facilitates and balances motivation with both higher and lower level functions. Brain imaging has shown that the inferior frontal gyrus is involved in resolving interference among competing actions. The ventral striatum is located in the limbic system. However, it has been shown to be associated with satisfying gratification urges. Now, what this means is that the ventral striatum, the more activity it has, the more impulses you're going to feel. So basically, it's centered around impulses. So if you want to do something, that's that part of the brain causing you to want to do something. The inferior frontal gyrus, on the other hand, is the part of the brain that controls and tones down these impulses. So it stops you from doing something that you may really want to do, but it could be negative on it could have a negative consequence or something. So it basically it's like a control center for these impulses. So background research. Research by this person called Egsti, I don't know how you pronounce their name, but in 2006, found that performance in preschool delay of gratification may predict the capacity in adulthood to control thoughts and actions, as reflected in performance on cognitive control tasks. So, the aim of this study was to build on previous research to assess whether delay of gratification in childhood predicts impulse control abilities and sensitivity to alluring or social cues, which in this study are happy faces, at the behavioural and neural level when participants were in their 40s. So obviously this is a longitudinal study. They take people who they used at a young age, I think maybe age 4, through to when they're 40, and they just study them at intervals, but it's a longitudinal study. Or at least partly it is anyway. So the alluring qualities of targets in an impulse control task were manipulated to examine behavioural and neural correlates of delay of gratification. So the research method, obviously this is just basic stuff, but let's get going, and you need to remember all of this stuff. So it is a natural experiment, as the IV of whether the participant was a high or low delayer is naturally occurring. The independent variable, the IV, was as just stated, was whether or not the participant was a high delayer or a low delayer. The dependent variable, on the other hand, was the performance on the impulse control task, and this is in terms of the reaction times and accuracy in experiment 1, and the performance on the impulse control task and the imaging results using an fMRI scanner in experiment 2. Some participants completed self-control scales when in their 20s and 30s, and those who participated in experiment 1 did both hot and cool go/no-go tasks. Basically, a go/no-go task is a task where you have to press a button when certain images appear, and not press a button when other images appear. So now we've got that cleared, the study had partly a repeated measures design. This is because the same people from a while ago were used in both conditions. As stated earlier, it's a longitudinal study, as the participants were studied from the age of 4 to their 40s. Sample. You don't have to know, it helps if you know all of this stuff, but I don't think you really have to know that they're like the 562 4-year-old pupils from Stanford Bing Nursery School. You have to know that there were a lot of 4-year-olds, but you don't have to know how many, I don't think. But if you can commit this stuff to memory, then do it. So 155 of the 562 completed self-control scales when in their 20s, and 135 of these did it when they were in their 30s. 117 of the 135 individuals who were above average or below average in their original delay of gratification performance, as well as in the self-report measures of self-control, were contacted in relation to participating in this study. Of these individuals who were contacted, 59 of the 117 agreed to participate in this longitudinal behavioural study, which is called Experiment 1. Participants were classified as low or high delayers from the results of A, their delay of gratification performance, and B, the self-control measures. In Experiment 1, there were 32 high delayers and 27 low delayers. So there's a roughly equal number of high and low delayers in this experiment, which is good, because it gives us a representative sample. So 27 of the 59 who participated in Experiment 1 agreed to be part of a functional neuroimaging study, which was Experiment 2. In this experiment, there were 15 high delayers and 11 low delayers. We have to note that there was one 41-year-old man who was excluded from all analysis because of poor performance. So his results, the results from Experiment 2 were just based on the results of the 26 other participants. Procedure for Experiment 1. This experiment tested whether individuals who were less able to delay gratification as children and young adults would, as adults in their 40s, show less impulse control in suppression of a response to hot relative to cool cues. So here it's worth noting that low delayers are the people that struggle to delay gratification, and I believe the test they did when they were 4 was a marshmallow test, and basically in this test an experimenter put a marshmallow in front of the children, and they were told that if they waited they would get another marshmallow, and if they wanted to eat the marshmallow now, then they could just eat that marshmallow. So low delayers were the people who just ate the marshmallow and didn't wait for 2 marshmallows, and the high delayers were people that could wait for the bigger reward, in this case being 2 marshmallows. So, and hot cues are basically something that we find alluring. So, say if it's a happy face, we'd find that alluring. If it's just a neutral face, that would just be a cool cue. It wouldn't really mean anything to us. So the 59 participants were already classified as high or low delayers, consented to take part in a behavioural version of a hot and a cool impulse control task. The participants completed 2 versions of the go/no-go task. The cool version of the task consisted of a male and female stimuli, which were presented one sex as a go and the other sex as a no-go. For a no-go, when the image appears on the screen, they were instructed to withhold their response, so they'd have a button to click, and they wouldn't click it for the no-go, but they had to click it for the go. You can actually download an app on your phone of like no-go tasks, so I'd advise you do that. Just go on the App Store and have a look, because it helps you get a better understanding of what these tasks actually are. So yeah, it would be similar to that. Before the onset of each run, a screen appeared indicating which stimulus category served as the target. Each face appeared for 500 milliseconds, followed by a 1 second interstimulus interval. 160 trials were presented per run in a pseudo-randomized order, 120 go to 40 no-go. It was a 2x2 factorial design, meaning that there was a male or female image, and there was 2 actions that you could take, being go or no-go. Accuracy and response latency data were acquired in 4 runs representing each combination of stimulus sex and trial type. The hot version of the go/no-go task was identical to the cool version, except that fearful and happy facial expressions served as stimuli. So the happy facial expressions would be the hot cues. The tasks were presented using programmed laptop computers, which were sent to the participants' homes. Procedure for Experiment 2. Using an fMRI scanner, participants were studied to examine the neural correlates of delay of gratification. It was anticipated that low delayers would show diminished activity in the right prefrontal cortex and amplified activity in the ventral striatum compared to high delayers. So as mentioned earlier, the ventral striatum is related to impulses, and it was predicted that low delayers, the people who struggle to control their impulses, would have higher activity in this region of the brain. 27 participants from Experiment 1 agreed to complete the imaging study. Participants completed a hot version of the go/no-go task, similar to that used in Experiment 1. Differences were in timing, number of trials, and apparatus. Each phase stimulus was presented for 500 milliseconds, followed by a jittered interval ranging from 2 to 14.5 seconds in duration, with a mean of 5.2 seconds. A total of 48 trials were presented per run in a pseudo-randomized order, 35 go to 30 no-go. In total, imaging data were required for 26 no-go trials and 70 go trials for each expression. The task was viewable by a rear projection screen and neuroscreen, 5-button response pad, recorded button responses and reaction times. One participant was excluded for excessively poor behavioural performance, as mentioned earlier, meaning that only 26 people's data could be used. In this study, rather than just being a 2x2 factorial design, it was a 2x2x2 factorial design. And I'm going to see you in the next video because I'm almost out of my time limit. So I'm going to make another video outlining the key findings and other and the conclusions, and then we'll be done. So thank you for listening. See you soon.